Good day, students. So welcome to mathgotserved.com. In this installment, we're going to be going over how to find the determinant and inverses of square matrices. Don't forget to visit our website at mathgotserved.com for a wide variety of math tutorials ranging from algebra all the way to calculus. Alright, so the instructions for the example are as follows. So for the given matrix, for the given matrix, we're to A, find the determinant. Find the determinant. Secondly, we are to state the significance of your result. So what does that, the answer you got from the determinant mean? State the significance of your result as it relates to the inverse. State the significance of your result as it relates to the inverse of that matrix. All right, and then lastly, you're to find the inverse of the matrix, and the inverse of the matrix if it exists. Okay. All right. Let's take a look at this square matrix right here for the first problem, question number 1. Let's say we have a 2 by 2 matrix, matrix A, as follows. So the elements are 1, 3, 5, 7. So we have 1, 3, 5, 7. So this is a 2 by 2 matrix because you have 2 rows and 2 columns. All right. So the first thing we're going to do is we're going to find the determinant of matrix A. So determinant of matrix A. The formula for the determinant is AD minus BC. This is the same thing as computing the product of the diagonal minus the product of the wings. All right, so in your matrix, this is your diagonal right here. All right, so that is the diagonal. And then this right here is known as your wings. So if you're looking for the determinant of a 2 by 2 matrix, you find the product of the diagonal and you subtract the product of the wings from that result. All right, so that's how you find the determinant of a matrix. Now, how about this ADBC business over here? How does that relate to this matrix? Well, this is how you label it. Starting from the top row, this is AB, and then drop down to the second row, CD. A, B, C, D. So that's how you alphabetize the elements in your matrix. All right. So AD, as you can see, is the product of the diagonal. BC is the product of the wings. So you find the difference of those two products, and that will give you the determinant of your matrix. All right. So let's go ahead and apply the formula AD minus BC to this matrix, to matrix A. Change my color there. So we're going to have AD is 1 times 7 minus BC. BC is 3 times 5. All right. So 1 times 7 is 7. 3 times 5 is 15. 7 minus 15 is negative 8. Okay, so that goes the determinant of your matrix. All right, now part B, what does this mean as it relates to the inverse of matrix A? Now, if you have a non-zero determinant, that means that the inverse of the matrix exists. But if the determinant is 0, then the inverse does not exist. So in this situation, since the determinant of matrix A is equal to negative 8, which is not equal to 0, the inverse, the inverse of matrix A to the negative 1, exists. So the inverse exists. Okay? So an easy way to determine if a matrix is invertible is by examining the value of the determinant. So if the determinant is 0, the matrix is not invertible, and if the determinant is non-zero, then it does have an inverse. Well, you might wonder why. Why is this the case? Well, let's look at part C. The formula for the inverse of a matrix will help you see why we have the result indicated in part B. So for part C, we're to find the inverse of matrix A. Okay? So let's see. The formula for the inverse of a matrix, let's go ahead and write that down. Formula again, A to the negative 1 is equal to 1 over AD minus BC times DA negative B negative C. Okay, so this is the formula for the inverse of a matrix. Now, if you take a look at this expression right here, 1 over AD minus BC, does anything look familiar to you? Let's focus in on the denominator. This AD minus BC, do you remember that expression showing up somewhere earlier? The answer is yes. There you have it right there. AD minus BC, that is the determinant of matrix A. So another way of writing down this formula is writing it as 1 over the determinant of matrix A times, now what is going on here? What's happening here is we have the diagonals flipped. Okay, we basically switched the diagonals. We had AD before, now you have DA. And then with the wings, you just basically take the opposite of the wings. Before you had BC, now you have negative B, negative C. So that's how you find the inverse of a matrix. You multiply the reciprocal of the determinant by the matrix you get when you switch the diagonals and take the opposite of the rows. Okay? Remember, this formula is just for 2 by 2 matrices. Now, do you see why a non-zero determinant is needed for the inverse to be defined? Look here, if this value, determinant of A, were 0, what will be happening in essence is you're going to be multiplying 1 over 0 times D, negative B, negative C, A. Now, do you see a problem with this picture here? 1 over 0 is undefined, hence this product is going to be undefined as a result of that. Now, since you're dividing by the determinant, it must have a non-zero value in order for the results to be defined. So that's why we have the situation in part B where the non-zero determinant implied that the inverse does in fact exist. Okay? Now let's go ahead and find the inverse of matrix A. So we're going to have 1 over, we already know what the determinant is, but let's just do it again. AD and BC. AD is 1 times 7 minus BC. BC is 3 times 5. And then times the matrix where you have the diagonal switched. A and D were 174, so you switch it around, you have 7, 1. And then as for the wings, what you do is you take the opposite of the wings. So negative 5 and negative 3. Let's simplify this further. You're going to have 1 over, where you know that the determinant is negative 8. All right, times 7, negative 3, negative 5, 1. Now this is just a scalar multiple. All you do is you just distribute this value to the elements of your matrix, okay? This negative 1 over 8. So if you go ahead and do that, you're going to have, let's see what we have, negative 7 over 8 positive 3 over 8, positive 5 over 8, and lastly, negative 1 over 8. This is the inverse of matrix A. All right, now I'm going to show you how to carry out these calculations using a TI-83 plus calculator. There are two ways you can enter in a matrix in a TI-83 calculator. I like to enter matrices using the home screen. So I'm going to enter matrix A into my calculator. So let's see. There you go. So matrix A, I'm just going to enter the rows first. So 1, 3 is a row 1. So I'll open my matrix with the bracket, and then I'm going to enter the first row, 1, comma 3. The elements of row 1 are separated by commas. Okay, so 1, comma 3. And then enter the second row, 5, comma 7. Close the second row, and then close the entire matrix. I'm going to store this in matrix A. So all I'll do is I'm going to call up matrix A by pressing second function x to the negative 1, which gives me access to the matrix menu. So second function x to the negative 1, enter to select matrix A, and I press enter. So this has been stored in matrix A. Now the first thing I calculated was the inverse. the determinant of matrix A. So let's go ahead and calculate that. So we're going to calculate the determinant. That's going to be in the math menu of the matrix menu. So you're going to go second function matrix. These are the matrix options. So we're going to go to math. Option 1, DET is your determinant function. So press enter. And I'm going to call up matrix A by pressing second function x to the negative 1 to go to my matrix menu. Enter to select matrix A. Enter, result negative 8. So we're confident that our answer is correct. Next thing we want to find is the inverse of matrix A. The inverse of matrix A. So that's pretty straightforward. All you just have to do is you're going to call matrix A again. Second function x to the negative 1. Enter for matrix A. And I'm going to raise it to the negative 1 power. Alright, so raise to the negative 1 like that. Press enter. Now this is the decimal representation of our result here, but I want to express it as fraction, okay? So to express my result as fraction, so I know for certainty that my result is in fact correct, I'll just go I'll just go math. You see this? Arrow and fraction changes your results to fraction form, alright? So press that button. So it says answer converted to fraction. Enter. You have negative 7 over 8, 3 over 8, 5 over 8, and negative 1, 8. Alright, so we can see that the result that we got for the inverse of matrix A is in fact correct. So thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. Do post a comment to let us know what you think about this presentation. And if you liked it, you can give us a thumbs up or favorite it and share it. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.